size has to be as per that. That's why you have to keep a section greater than 150 as per this recent code for the beam section. क्योंकि अगर आप दो ही bars इस्तेमाल करोगे, you will still be requiring at least 150 plus the cover on the both the sides. So it could easily go to 250 minimum width of the or around 230 which is 9 inch. So even for 2 bars you would be requiring that much amount of. So this is what is recommended, the clear distance, what is recommended between, but you can keep less than this between the 2 bars, but you cannot reduce it below 75 at any cost. 75 से कम तो कभी नहीं जाना चाहिए, the distance between the bars in this, which so this distance from this point right up till this point, you have to at least keep it at least 75. Right now from the code we are getting it, it has to be recommended value is 150 between 2 bars for FE500 at zero redistribution, but that does not stop you from keeping greater than 150 You can easily keep it above 150 This is a recommended value. 150 is a recommended value. So you can easily keep it as 300 up till 300 you can keep the distance between the 2 bars. Like there is a above 300 you cannot go above 300 So there is a limit to the spacing of the bars above 300 and below 75, and there is a clause related to that in the code itself. Just after this.
सर ये बार्स इक्वल डिस्टेंस पे होने चाहिए.
Means
सर अगर 3 बार्स होंगे तो वो अगर 75 हम लेंगे, 150 अगर हम लेंगे तो मतलब 150 और 150 हर 2 बार्स के बीच में 150 होना चाहिए.
No, it not, but your all bars should be symmetrically placed. हाँ, आप सही कह रहे हो, they should be, कोड में कहीं पर नहीं लिखा है that they should be symmetrically placed or not, but you have to provide it symmetrically, and you should always have this practice at the field that you provide them symmetrically. Here it's written in this, in no case shall the spacing exceed 300 between the bars. So this is mentioned here. So you have to ensure that it does not exceed 300 this is for the shear reinforcement, even for tension reinforcement. Just a minute. Maximum reinforcement, this here is the clause 0.04 BD, जो कि हमने अभी पढ़ा. Now, it is, once you now know the spacing between bars, you have to, so you are then fixing the spacing between the bars, and you are then placing the bars accordingly. Now you have to decide first of all कितने bars हमें place करने हैं as per area of steel required, और उनके बीच में हमें spacing कितनी देनी है. तो उसमें ये भी ध्यान रखना है कि spacings between the bars have to be ensured कि वो 75 और 300 के बीच में हो, and around recommended value जो 150 है उसी के आसपास हो. That would be a good thing. So, and then the code also mentions about the side face reinforcement that you provide. So it was given there. The spacing of this side face reinforcement, when the depth of the beam exceeds here, when this clause, when the depth of the beam in a beam exceeds 750 side face reinforcement has to be provided on 2 faces. The total area shall be less than 0.1% of the web area and shall be distributed equally on the 2 faces at a spacing not exceeding 300 So what it wants to say is that you have this as the beam, if it's exceeding 750 mm in this dimension, if this is increasing 750 mm, in that case, what do you do? In that case, पेन नहीं मिल रहा मुझे, कहाँ का पेन? So this is 0.1%. Sorry, not here. Here, यहाँ पर बीच में हमें, not here. At this point, at two faces, you will be providing 0.1%. इसका area जो होगा, AS of side reinforcement, ASS, it will be 0.1% of web area. And what is your web area? Web area is सबको हम कह रहे हैं web area, which is B into D, small d. That's web area. So it will be 0.1% of that. Percent means 0.1 divided by 100. So that will be the area of reinforcement. So it will be 0.001 into BD. And it will be distributed. तो इसमें जो आ रहा ASS उसका आधा इधर देंगे और आधा इधर देंगे. So on each face it will be actually just 0.05 of BD. तो ये हमें साइड फेस रेनफोर्समेंट यहाँ पर प्रोवाइड करनी है. तो इनके बीच पे भी स्पेसिंग्स 300 mm at a spacing not exceeding 300 mm, whichever is less, और वेब थिकनेस. तो ये साइड्स रेनफोर्समेंट वो भी हम इंश्योर करेंगे. तो अगर इस ये विड्थ ज्यादा है, if this width is more, then what we do, we can also provide side face reinforcement even at the center. But at the same time, we have to also fix on this side 300 mm. If this is way larger, अगर ये 1000 for example 1000 mm है, 1000 mm है 1 मीटर की बीम है, तो यहाँ तो एक बार होगा और ऊपर एक और बार होगा. तो इनके बीच में there will be around 900 mm कवर को काट के 900 mm will be there. So it will be 450 mm अगर यहाँ हम एक बार बीच में दे, तो 300 mm से ज्यादा एक्सीड नहीं करना चाहिए. So we have to provide two then, somewhat like this. In that case, we have to provide somewhat like this. एक बार यहाँ पर, फिर एक और साइड reinforcement somewhat like this, और ऊपर एंकर बार्स होंगे एंड नीचे आपके टेंसाइल longitudinal bars होंगे. This is how it has to be in case. So as you have this being listed. Okay. So spacing between the bars, आपकी अब आ रही है. You are now clear. Then you are clear about side face reinforcement. तो उसके बाद हमें क्या डिजाइन करना है? That is stirrups. So finally, in the last step, before we check for deflections and other things, we will be designing this stirrups, which are rings. Now, how are they designed and on what basis are they designed? So there is a clear-cut guideline for this, that you have, they are designed for shear. We know that they are designed for shear. And what is shear force on the section will be VU. In this step, once we were calculating the bending moment here, we can also calculate the shear forces VU in the same step. So its shear forces would be something like this, and this would be VU, or it could be V. For V is your stresses and VU is your ultimate shear resistance. So we initially assumed that V is equal to VU. Later on, the design takes care that V will be less than VU. So you will get V there. So what will be VU there for this section? It will be WL by 2 So you will be knowing W is dead load plus live load into load factor, and you will be knowing V already or VU already. So this is your shear resistance of the section. Or if you equate it with the shear stresses initially, then it is shear stresses as well for the loaded section, taking into account the load factor as well. तो ये आपका shear resistance भी है, and or that as well the stresses. You're equating the both the things together right now. लेकिन एक सेक्शन किस चीज का बना है? We now know that it is made up of concrete, it's made up of steel. तो तीन चीजें शेयर के लिए रेजिस्ट करती है. वन, कंक्रीट रेजिस्ट शेयर. सेकंड, स्टायरप्स resist shear. Third, the bent up bars resist shear. So three things resist shear in a beam section. एक बीम सेक्शन में तीन चीजें रेजिस्ट कर रही है शेयर फोर्सेस को. तो मैंने ये ऑलरेडी कहा कि शेयर फोर्सेस एक्ट मैक्सिमम अलोंग द सेंट्रल प्लेन. सो अलोंग द सेंट्रल प्लेन, एक तो मैंने ये भी कहा आपको कि स्टायरअप ये रिंग होगा एक, तो यहाँ पर रेजिस्ट करेगा, यहाँ इस साइड से रेजिस्ट करेगा. तो बीच में कंक्रीट है वो रेजिस्ट करेगा. सो कंक्रीट इज रेजिस्टिंग हियर एट द सेंटर. ये स्टायरअप्स रेजिस्ट कर रहे हैं हियर. Then there are bent up bars as well which are resisting shear. What is a bent up bar? एक बीम है along the length. तो सबसे ज्यादा shear, we just saw that maximum shear कहां पर आता है? Towards the supports. तो सबसे ज्यादा shear acts towards the supports here along this boundary, around in 0.15 15% distance of the span, total length of this beam. On either side, most of the shear forces are acting there from the support end. So around 15% of the beam on the either side, that is 30% together, वहां पर सबसे ज्यादा shear forces act कर रहे होते हैं. तो हम क्या करते हैं, because there are maximum shear forces there, एक टेंसाइल बार जो होगा, वो टेंसाइल बार लॉन्गिट्यूडनल बार कहां पर चलेगा? नीचे. हमने ऑलरेडी देखा सेक्शन में नीचे, यहां पर दिस इज योर सेक्शन, तो नीचे यहां पर एक टेंसाइल लॉन्गिट्यूडनल बार है. सो वी कॉल दिस एज लॉन्गिट्यूडनल बिकॉज इट्स रनिंग लॉन्गिट्यूडनली. तो ये रेड कलर का दिस वन, दीज आर एट द बॉटम ऑफ द बीम. तो क्योंकि यहां पर शेयर फोर्सेस ज्यादा है, हम क्या करते हैं, we also have tensile force bending moments more towards the ends. If it's simply supported, no issue with the tensile forces. But for fixed, आपने देखा होगा कि bending moments for fixed condition क्या होती है? Somewhat like this. अगर fixed bar होगा, then have you studied this? Bending moment diagram will be like this. Yes, any one of you? It will be sagging here and it will be hogging towards the ends. तो इसका ये मतलब है कि towards the ends जहां पर support है, वहां पर आपको tensile forces are acting. Hogging means, hogging का ये मतलब है कि tensile force ऊपर की ओर act कर रहा है. It's bending towards the top, so tension happens towards the top. और sagging का ये मतलब है कि ये नीचे से bend कर रहा है. तो यहाँ पर जैसे कि simply supported में नीचे से bend कर रहा था, तो tension was towards the bottom. तो जब हम पहले यहाँ पर बात कर रहे थे, tension is towards the bottom, it is when it is simply supported and at the center portion. For a fixed end condition, you will have tensile forces towards the top here. तो ये बार हमें ऑटोमेटिकली फिर शिफ्ट करना पड़ता है. दिस बार वी हैव टू शिफ्ट दिस टुवर्ड्स द टॉप, सपोर्ट्स के पास जाकर, जहां पर आपका बेंडिंग मोमेंट ऐसे ऊपर की ओर, हॉगिंग की ओर जा रहा है. तो आपने देखा होगा कि लोहा एंड्स पे, स्लैब्स में, बीम्स में उसको ऊपर बेंट अप करते हैं. सो द रीजन फॉर बेंडिंग दैट अप is this, that it is going tensile towards the corners. So wahan par hogging is developing towards the top, so there is a tension developing towards the top. It may also happen in a simply supported beam अगर वो properly lift ना करे, and there is nothing like a proper simple support in concrete structures, क्योंकि एक बीम के ऊपर there will, अगर वो rest भी कर रही होगी just resting on walls, उसके ऊपर there will be certain some other wall as well over it, so it will never be properly simply supported, there will be some amount of fixity to that beam there. तो हम इसीलिए bend up करते हैं. One reason for bending up is that. Another reason for bending up is you now can also provide for the shear. So you will have double one bar at the bottom and one bar at the top, which is both are taking the shear forces, and then shears towards the end they propagate, क्योंकि यहाँ तक तो ये ऐसे चलता है shear forces, then they will shift because they have to go towards support, they will go like this. So to resist this action of shear जो कि angle पे फिर जाता है, अगर point load यहाँ पर है, the shear forces travel mostly through the center, but towards the ends they go like this because they have to travel down into this column, the shear forces. So we provide a section resisting the plane of the shear force at 45 degree. We usually bend it up at 45 degree, but you can bend it up from 30 degree up till 60 degree. We can bend up the bars from 30 degree up till 60 degree. We can, for practical purposes, it's easy to bend at 45 degree. And तो ये तीनों चीजें resist करते हैं to the shear forces. One, concrete, second, stirrup, and third, the bender bars. So we know VU, if VU is known, so we first need to calculate what is the shear resistance offered by concrete. So VU will be addition of VC. VC is the shear resistance offered by concrete. ये पहला वाला. Second, it will be by the stirrups, VS. And third, it will be by the bender bars, which we can either neglect. But what the code does, code takes both concrete and stirrups bender bars together under the term VC. So we don't need to have another third term here. Code इन दोनों को आपस में combine करके it determines VC. How does it do that? There is a table given in the code. This is the table. This is design shear strength of concrete tau C, but this is tau C, not VC in the code. It's giving in terms of the shear stress. So for grade of concrete that you will be using, now you have already decided the grade of concrete. For example, it's M20. You will have to check what is the area of the longitudinal tension reinforcement that you have already used, because that will serve you the purpose of the bent up bars का क्या function है. ये भी आपने already determine किया होगा, आपने इसमें longitudinal tension bars आप डाले हैं already by the time you reach to the design of stirrup. तो ये आपको इसका area of ये for example it's 1, so we'll take tau c as 0.62 from this code, and this will be your tau c. If you know tau c, then your VU will be tau c into BD, because tau c is, what is tau c? Tau c is your shear stress, but you need to know shear force. It will be tau c into BD, because tau c would be VC by BD, the overall depth, plus VS. So if you know VU, tau c is given from the code, B आपको पता है by now, DB आपको पता है, so you can get VS. तो VS आपको, you will be now getting the value of Vs. What is Vs? Vs has stirrups आपको क्या चाहिए, कितने चाहिए. This is the stirrups that you require for this section. So this stirrup Vs, again going back to the code, Vs or VUS. The code has used the term VUS for Vs, is then equal to 0.87. Now you already calculated VUS from the formula I just showed you. Then your VUS will be equal to 0.87 Fy ASV into D by SV. This is from code. So Fy is known to you, your D is known to you. SV and ASV you will get from the code. Now what is ASV and SV? SV आपका spacing है stirrups का or bent up bars along the length. And what is your SV? Sorry, it's ASV. ASV is the total cross-sectional area of the stirrup legs. So this is your formula, 0.87 Fy ASV D by SV. So you have the value of VUS or VS. VUS, you can say this is VUS as per code. So you have this 0.87 Fy ASV D by SV. यही था. Yes. So you have ये value आपको, you will get a ratio of ASV by SV because this is known to you now from this formula. These other values are known, so you will get the value of this ASV by SV. What is ASV by SV? ये आपकी beam है, and then you have stirrup inside it. उसका क्रॉस सेक्शनल एरिया जो है स्टायरअप का, ये 2 पॉइंट्स पे शेयर प्लेन काटता है. एक तो यहां पर काट रहा है इसको और यहां पर काट रहा है. तो 2 प्लेन्स पे देयर आर 2 पॉइंट्स वेयर द शेयर प्लेन इज कटिंग द स्टायरअप. तो 2 शेयर रेजिस्टिंग पॉइंट्स आते हैं एक स्टायरअप में. सो ASV विल बी 2 of 2 times pi into phi of t, I'll say here, square by 4. So this is phi t. Phi t क्या है? Phi t इसका डायमीटर है. किसका? स्टायरअप का. कहां पर 2 पॉइंट्स पे ये इसको शेयर प्लेन काट रहा है, तो 2 एरिया ऑफ क्रॉस सेक्शंस इसको काट रहे हैं. तो this is your ASV, 2 times phi into this. And what is your SV? Now if you check shear forces along the length, so now you have a bar at the bottom, bar, anchor bar at the top, और उनके बीच में you have many stirrups और rings आपने देखे होंगे beams में डालते हुए. So this is how we provide the rings. ये cross sectional area along the length है of the beam. So similarly continuing, तो ये spacing है between these. Why do we provide spacing in between? Because they will be resisting along the length as well. So because the loads, the shear loads are coming like this, they are transferring like this, and then they are going like this. So they will continuously be crossing through the stirrups, and stirrups are being provided such that वो उसको it does not fail in shear at regular intervals. So we provide at regular intervals stirrups which are vertical, or we can also provide towards the ends as oblique stirrups ऐसे डाल सकते हैं. But we usually provide vertical stirrups ऐसे डालते हैं along the length. तो ये stirrup, ये black वाला, this is your black, these lines along the face अगर हम beam का section काटे, तो इनके बीच में ये SV है spacing. right from here up till this point, it is SV. ये spacing है इनके बीच में. That is your SV here in this formula. Now, how much do we fix SV? Again, code tells us you have to go and check the code again for this, that there was already spacing there. What was the page number जहाँ पर spacings दिए हुए थे? That's it. Yeah, there it is. Maximum spacing of shear reinforcement shall not exceed 0.75 D for vertical stirrups and D for inclined stirrups. So your just a minute. ये आपको already पता है. This is your effective depth D, and then your spacing between the stirrups shall not exceed 0.75 D. अगर आप stirrups at 40 for inclined stirrups at 45 degree दे रहे हो, and in no case shall the spacing exceed 300 mm. तो ये आपका this is your as per the maximum spacing that you can keep for stirrup. Even the minimum spacing, which code has not mentioned here, that has to be fixed for the stirrups as well. So this again has to be zero. This has to be 75 mm. Say start okay, you can go up till 300 mm the stirrup spacing. Lekin the minimum that you provide is 75 and maximum is 300. You can go for 0.75 D as per the provision. Agar aapka depth, for example, 300 mm hai, so this will be easily 200 mm. But in no case shall it exceed 300 mm. अगर यहाँ से आपको 300 mm से ज़्यादा भी आता है 0.75 D से, this is your D जो कि कोड में मेंशन है, but you will still keep it restricted to 300 mm. तो ये आपकी स्पेसिंग आएगी. But here from this formula, अगर आप ASV यहीं से दे रहे हो, FY भी आपको पता है, VUS भी पता है, D is also known, so you will directly get SV. Now SV that you get, that has to be greater than SV जो आपको यहाँ से मिलेगा from this formula, it has to be greater than 75 mm and it has to be less than 300 mm or 0.75 D. तो ये conditions है. You will come to understand this once we start the questions from the next class. We'll be taking about design questions immediately in the next class onwards, inshallah. So one more thing related to deflection, we'll do that in the class itself regarding that design question. So from